All right, let's dive right in. Today, we're basically handing you a field guide to the entire universe, a way to understand the stuff that makes up, well, everything. Ready to become an explorer? Let's do it.
I mean, have you ever really thought about it? If you could zoom in, way, way in, past the screen you're looking at, past the molecules, past everything, what would you actually find? What are the fundamental building blocks of reality?
And that's exactly what we're here to do. Think of this as your personal handbook for that expedition. We're going to give you the tools to identify the basic components of the world.
Okay, so every good guide starts with the basics, right? We just need to get on the same page with two key terms. Master these, and everything else will click into place.
First up, chemistry. And I know that word can sound a little intimidating, but trust me, it's not. All it really is the science of stuff. What stuff is, how it's put together, and how it can change. It's the official rulebook for our entire guide.
And all that stuff we keep talking about? Well, in science, we call it matter. It's a super simple but really powerful idea. If it has weight and it takes up space, it's matter. The chair you're on, the air you're breathing, it's all matter. And that's what we're investigating today.
Okay, so our target is matter. Now, the first skill any good explorer needs is classification. When you look at something, you need to be able to tell, is this one single, pure thing? Or is it a jumble of different things all mixed together?
A pure substance is, well, it's exactly what it sounds like. It's made of only one type of particle. Think of a bar of pure gold. Every single tiny atom in there is a gold atom. That's it. Or a glass of pure water. Every single molecule is H2O. It's consistent all the way through.
A mixture, on the other hand, is a little messier. It's when you have different kinds of matter just hanging out in the same space. The crucial part here is that they haven't chemically bonded together to become something new. They're just physically jumbled up. And we can even get more specific. You have homogeneous mixtures, which are blended so perfectly they look like a single substance. You know, like when salt disappears into water. You can't see the individual salt bits anymore, right? Then you have heterogeneous mixtures. Here you can see the different parts. Think of a piece of granite or a salad. You can easily point out all the different components.
All right, so we've got a handle on classifying what matter is. Now for the really fun part, what does matter do? This is where we learn to spot the difference between something just changing its appearance and something fundamentally becoming a brand new substance.
And this distinction is absolutely crucial. A physical change just alters the form. When an ice cube melts into water, it's still H2O. It just went from a solid to a liquid. But a chemical change, that creates something entirely new. When a log burns, the wood is literally gone. It has been transformed into new things, ash, smoke, gases, all with totally new properties.
So how do you spot one of these in the wild? Your field guide has 5 big clues. Look for heat or light being produced. Look for a solid suddenly appearing in a liquid. Are there bubbles? That means a gas is being created. Did the color change permanently? And here's the big one. Is it really, really hard to reverse? If you're seeing these signs, you've likely witnessed a chemical change.
And scientists use these clues as actual proof. This is so cool. Take the classic test for hydrogen gas. If you think you've made hydrogen, you bring a lit stick close to it, and if you hear a sharp pop, that's it. You've just proven it's hydrogen. That little pop is a tiny explosion, a rapid-fire chemical reaction, and a perfect example of this in action.
So we know that reactions happen. But to understand why some things go pop and others do nothing, we need a map. And for chemistry, the ultimate map, the most powerful tool we have, is the periodic table. Now, it might look like just a random jumble of boxes, but I promise you, it's an absolute work of art. It was first organized by Dmitry Mendeleev way back in 1869, and every single element has its place for very specific reason. It's a map that reveals deep secrets about how the universe is built.
So let's decode it real quick. The rows going side to side are called periods. The columns going up and down, those are called families. And this is the genius part. Elements in the same family behave in similar ways. And you see that bold staircase line? That's a major dividing line. Everything to the left is a metal, everything to the right is a non-metal. Simple, elegant, and so powerful.
Now that we see the layout of the map, let's zoom in on one of those squares and learn how to read the secrets packed inside.
Okay, the single most important number here is the atomic number. This tells you how many protons are in the core of one atom of that element. And that number is everything. It's the element's unique, unchangeable identity. It's what makes it, well, it.
So, for example, look at this number, 29.
If you have an atom and you know for a fact it has 29 protons, what is it?
It's copper. Always. It doesn't matter if it's on Earth or in a galaxy a billion light years away. If it has 29 protons, it is a copper atom. Period. That's the power of the atomic number. It's like a cosmic fingerprint.
The other key number is the atomic mass. This is basically how heavy an average atom of that element is. So for copper, its identity is number 29, but its average weight is about 63.55.
And remember those families? Here are 4 you should totally know. Way over on the left, you've got the alkaline metals. These guys are so reactive, they practically explode on contact with water. Next door are the alkaline earth metals, a little calmer, but still very reactive. Then jump all the way to the other side, near the end. Those are the halogens, also super reactive. And in the very last column, the noble gases. They're the cool kids at the table, so stable they barely react with anything at all.
So there you have it, your starter pack, your field guide to matter. You now know how to tell the difference between pure stuff and mixtures, you know the clues for a chemical reaction, and you can read the ultimate map of the elements. So the only question is, now that you have the guide, what will you see? What's happening around you right now that you can finally understand in a whole new way?